possible cause of crash, physical consideration. Well, this is the third videos. I got new information, and the purpose of this video is for you to use your physics knowledge to think independently, apply your physics skills independently to see what kind of argument you can make. Okay, here's a speculation, but one interesting aspect came out, and I want to introduce that to you. Okay, this airplane has the detector of pitch, and basically what it looks like is the dial is printed, right? And this is -5 degree going down. This is +5 degree going up. And this dial, the needle, is actually a little fin. From top view, it looks like that, and it's spin around, depend on winds. So when you are level, then the dial pointing here and say your nose is level. When you start pitching down, then this dial rotate, right? So dial is printed on the body, so it's going to be like, and -5 and +5. When nose is down, it's supposed to indicate, well, I was wrong, it should be opposite, right? So since this guy, if you're moving straight, then it's indicated here your nose is, the pitch is down by 5 degree. Okay, now think about this. This dial does not give you the correct information. Okay, because when nose is down, yes, initially you're still going horizontally, but in a few seconds you start going down. So the wind's gonna push dial to this way, right? And this is neutral. So dial will give you the information that, hey, your nose is straight even you're going down at the 5 degree pitch, right? Okay, so this will give you only between the airplane moving horizontally to start moving 5 degree going down. This between few seconds give you that dial move to -5, means nose down. Okay, I don't know how the software is detecting this, but this is kind of very dangerous to say how many seconds it takes to actually start moving at the 5 degree going down, right? From horizontal position, horizontal to 5 degree movement. Only this transition, this dial works. Okay, now another problem here is when you have nose down, okay, and going this way, then as I said, the dial neutral show here, and +5 and -5. And since you're moving this way, the wind brought the dial to here, so it doesn't show your pitch is going down. And suppose to correct this, right, you start moving the trim, the roll up to bring the nose up, okay, but your software doesn't show that is necessary until you start moving up. Then when the airplane start going up and go horizontal, then finally that during transition this detector shows the change, okay? And the software don't know exactly how long it shows, depend on situation and speed, okay? Then for example, when you are pitch up, right, then dial is like this, and right, okay, and if you're moving up at the 5-degree climbing, then air flow this way, so the dial is pointing this guy, and software doesn't know you're climbing up, it's just, you know, climbing up straight. Okay, now suppose you reduce the thrust here, then the speed start increasing and you're not climbing up anymore, it start going this way. So suddenly you start seeing that the dial start moving this way. So you slow down, then software thinks, oh, you move the nose up, the pitch up. No, you're not moving pitch up. You just slow down, because for this position you are climbing at 5 and you slow down, then gradually the wind direction change from here to here. So dial start moving toward this guy, and software thinks, oh, your nose is up. So, you know, if software automatically correct that, it's going to push this down by moving trim. Okay, so it's really erroneous information. It's not accurate information at all. This detector of nose position is totally flawed, in my opinion. This kind of simple detector cannot be used for software to control the trim. It's very dangerous, because who knows, you're slowing down or you're speeding up, all depend on the parameter. The dial keep moving around and doesn't show the correct nose position. It's up or down. It's really complicated, and software can't use this kind of input to control the airplane. So many different cases we have to go through and see what happened for each cases, and the software has to be corrected. And also the problem is that during transition the dial change position, and we don't know exactly how long it's going to take, and software use that information. How many seconds is valid? 2 seconds or 3 seconds, 4 seconds? So it's really like using a bad input, feeding bad input to the software, and depend on the situation it's happened. The pilot reported it doesn't gain the altitude. You try to move up the nose, then software resisted. And exactly this case, if you start moving up, then the velocity decrease, then needle start moving up and it show as nose up. And if speed decrease a lot, then it looks like as if it's you are moving nose too much, so software push it down. Then speed is low and nose push down by moving this trim, then what happened? It starts sinking. Then pilot start moving the nose up again by trim. Then pilot try to move, but softwares go opposite. It's gonna fight. So this all come from the change of the position of engine. In the second video, the moving up engine basically close to the center of gravity, you lose the nose up moment by thrust. All you have is lift, and lift work on nose down. Okay, so you don't have much nose up by thrust. When you try to gain the altitude, you increase the thrust. It's supposed to nose up, but it doesn't nose down. Nose doesn't go up. And what happens is, all kind of things happen depend on this dial. This dial is faulty, and you can't make a software based on this input from this dial. Okay, that's my thought. So there may be, the Boeing may have a good explanation of why this dial works. I don't know, but independently thinking that this kind of dial doesn't give really reliable data. And if software is written based on this, why it's not reliable? Because during a transition it changes, and you don't know how long is a transition. It's depends on speed and air conditions. Air may be blowing down or up. Who knows? It's very unreliable data. So this is another thing. New information came up. I didn't know what kind of detection device Boeing is using to drive the software, but this is very simple, but it's very faulty information. Okay, it could be a very bad news. I don't know, but just wanted to tell you that you have to think independently and judge yourself. Okay, thank you for listening, and if you like, subscribe.